Okay, right now I want to talk about 2010 number 2 from the Calc AB free response. And here in this problem is given to us this particular table with t from 0 to 8, and these are very specific values. And then you have e of t 0, 4, 13, 21, 23. And here's the problem. Now every time I see this problem I immediately think of, okay, this has to do with instead of a function, okay, or a graph, it gives you a table. But I think it's helpful to turn this into a graph so that you can conceptualize it based on the concepts that we study. Now let's read this problem together. A zoo sponsored a one-day contest to name a few baby elephants. Zoo visitors deposited entries in a special box between noon t equal to 0 and 8 p.m., which is t equal to 8. So we start out with an entry, e of t, going from t equal to 0 to t equal to 8. Okay. Now the number, the value of e of t is given in hundreds of entries at various times shown in here. So t equal to 2, we have 400 entries and so on. So that's an example. Now here part A says we want to use the data of this table to find the approximate the rate at which entries will be deposited at time t equal to 6. Now I think it's very helpful for us to kind of turn this into some sort of graph. So I'm just going to go ahead and put it right here. And this is just something that we can be able to kind of conceptualize it. And so on the bottom here is t, and on top e of t. Okay, and at t equals 0 is 0. At 2, here is 4. At 5, we get 13. At 7, we get 21. And at 8, we get 23. So go ahead and give corresponding values, corresponding dots right here. Okay. So in a sense, this could be a function that goes along these lines, but along these points, but we don't really know the function. So the only information we have are these discrete values. So we can think of it as these are simply just, these are the ones that we got. Okay. Now here we want to try and define the approximate rate. Now when we think of rates, now entries, these are the actual value, the number of entries. So when we're talking about the rate of entries, we're talking about derivatives. Or better yet, instantaneous rate of change. Now we want to find it at t equal to 6. The t equal to 6 is right here. We don't have t equal to 6. So the only thing that we can find is based on what's closest to closest to t equal to 6, which is between 5 and 7. So we're talking about right here. What's the instantaneous rate at this point? But we don't have a value here, so the only thing we can use are the ones at t equal to 5 and t equal to 7. So this is what we need to find. We need to find the average rate. That is the approximate instantaneous rate at t equal to 6. So average rate between 5 and 7. 5 and 7. So that's easy. We know that that has to be e of 7 minus e of 5 over 7 minus 5. And if you take a look at what we have 21 minus 13 over 7 minus 5. So we end up with 4. And and so there's 400 entries per hour. Okay, so that's part A. Now part B, let's take a look at part B. Part B says use trapezoidal sum for the 4 subintervals given by the table to approximate the value. We want to approximate 1/8 definite integral going from 0 to 8 e of t dt. Okay? Well, first of all, we need to find out what it is. Well, integral. We know that definite integral is the area under the graph. Now, we want the problem asks us to use 4 subintervals. Now, it didn't say 4 equal subintervals. Simply say 4 subintervals. The reason why is because we only have these discrete values to work with. So basically, this is what we want to find. We want to use these values, and these are the areas that we need to look for: A1, A2, A3, A4, right? So it's equal to 1/8 times A1 plus A2 plus A3 plus A4. Now, I hope you all know how to solve this. Well, the first one is this triangle. So it's the area of this triangle, 1/2 base times height. A2 is the trapezoid. So it's 2 bases times the width divided by 2. And same thing for A3, the trapezoid, A4, the trapezoid. So by skipping, I'm going to go ahead and skip the algebraic computation. The answer is, once you figure all that, looking for those values, your answer ends up to be 10.68, 100 entries per hour. Now, why do I say that? Well, the actual area under the graph, right, is the actual number of entries, the total entries. But this 8 right here basically is the 8 hours. So you get total number of entries divided by 8 hours gives you 10.68 hundredths of entries per hour. What does that mean? Here is asking, the second part of the problem is asking, well, explain the meaning of this answer. Well, this answer simply means it's the average entries per hour. Average entries per hour. Notice this corresponds to the calculus concept of average value. In calculus, every time you deal with average value, every time you hear and read average value, this is what you need to immediately think about. It is an average value is equal to the integral from a to b f of x dx divided by b minus a. Now, doesn't this look exactly the same as this? Integral from 0 to 8, instead of f of x is e of t dt divided by b minus a will be 8 minus 0. And so part B is asking for the average value. Now, we're ready to work on part C. Let's read this together. Now, the entries, number of entries that was turning was from time equals 0 to time equal to 8, which is going from noon to 8 p.m. Now, part C says, then at 8 p.m., volunteers begin to process all these entries, and they process the entry at a rate modeled by this. This is a rate of processing P, and P of T is written right here in a problem. P of T is equal to T cubed minus 30T squared plus 298T minus 976. And these are in hundreds of entries per hour. Hundreds of entries per hour. Now units are very important in these problems because they indicate to you whether they are the actual rates or the actual entries. So in this case it's rates, entries per hour. Now according to this model, the question is how many entries had not been yet processed by midnight. The entries that had not yet been processed by midnight. Not yet processed. Now, not yet processed. And this is to talk about not yet processed in the unit of actual entries. Well, wouldn't that be the total number of entries minus the number of processed entries, right? Now the total number of entries, what do you think it was? Well, first of all, the total number of entries, and you remember, part B says that we have processed, we have entered 10.68 hundreds of entries per hour, right? Hundreds of entries per hour. I'm just going to use this. Hundreds of entries per hour. For how many hours? Well, for 8 hours. Now, we need to subtract the total number of process entries. And the process entries, and here we have the rate of processing. So basically, it is integral of the process rate, right? So it's integral of T cubed minus 30T squared plus 298T minus 976 and parentheses dt going from 0 to 8. Now, for this total number of entries, we didn't have any functions to work with. So we only work with the table. And this was the average value over 8 hours. So we take the average value of the average entries per hours over 8 hours, multiply by 8 hours, we get the total number of entries. But we need to subtract the number of process entries based on this equation is given to us, which is the rate of processing. Now, this number is very easy, and this is number 2, so it's part of the calculator problem. So what you can do is you can use your calculator. Okay, you can use your nice dandy graphing calculator. You can put this equation into y1. Right? You will put this into your calculator. X cubed minus 30x squared plus 298x minus 976, and so on. And what you can do is you can graph it. Make sure you have the right domain and everything. You can see the whole graph. And then you can go to second, trace, and then you can select the function for getting the definite integral. So based on my calculation using my graphing calculator, I end up with this, for this one, I will end up with 85.44 subtract this one comes out to be 16 hundredths. So by subtracting these two, I end up with 69.44 hundredths of entries, and that's the number of entries that's not yet being processed. Okay, so now I'm gonna go ahead and do part D. And let me go ahead and erase this part. Let me go ahead and erase this part. Now, part D says, according to the model from part C, and what's the model? The model, this is part D, so model was P of T is equal to TQ minus 30T squared plus 298T minus 976. That's the model, that's the rate of process. And here it says, according to this model, at what time will the entries being processed most quickly? Now when you hear the word quickly or most quickly, the term most, in calculus we think of extrema, we think of maximum, and we immediately think of first derivative test. So we're talking about the first derivative test, right? We're talking about first derivative test of what? Of the rate, or the fastest rate. So we have to do the first derivative test of P of T. So we can go ahead and take the first derivative, P prime of T gives you 3T squared minus 60T plus 298, and you set it equal to 0. Now, what you can do, now this is the algebra problem, but it's in problem number 2. So you don't have to solve this by hand. So what you can do is you can use your calculator. Okay, set y1, so clear the previous entry in your y1 and put this in your y1, so you get 3x squared minus 60x plus 298, graph it, and then you can use the functionality in the second trace, which gives you calculate and give you the open functions, and you can look for zeros. And this will then take you to the graph. You identify which is zeros, and you identify a couple things. This is the result that you get. You get t equal to 9.18 on one hand, and you get 10.846 on the other hand. So then we're going to go ahead and do the first derivative test. We get 9.18 right here, 10.84 right here. This is t, and this is p prime. Over here at p prime are going to be 0, and you also notice that the domain, right? The domain is going to go from 8 to midnight, which is 12, right? 8, which you see the entries was given all the way into 8, but processing entries started at 8 p.m. all the way to midnight, so it's 8 to 12. Okay, so what we need to do is we need to find the value in between 8 and 9.18. Pick 9, for example. If you put 9 and you put it into into p prime, okay, if you put it into p prime, so 3 times 9 squared minus 60 times 9 plus 298, you calculate it, it should give you plus, which means it's going to go up. You can pick a number between here, between 9.18 and 10.84, pick 10 for example, put 10 into here, so 3 times 10 squared minus 60 times 10 plus 298, you should get a negative value. Now, you don't really have to finish this. You now know that the rate at t equal to 9.18 is going to give you the maximum. So you can go ahead and say at t equals 9.18, the processing rate p of t is max, or is being processed most quickly. Okay?